Prometheus is a monitoring tool that could be used in Kubernetes in order to scrape metrics from the pods, the nodes, and the application itself in order to get an overview about the health of our application and our cluster. Today, we'll learn how to install Prometheus into a Kubernetes cluster using Helm charts. Then we'll see how we can customize the default configuration in order to scrape metrics not only from the cluster itself, but also to scrape metrics from the application. So let's do that. I have already created an ASP.NET Core application, and I have installed the Prometheus NuGet package, and I have enabled exporting Prometheus metrics. For that, I have here this instruction app use metric server, and here I expose those metrics on a public endpoint URL, which is /metrics. I have also created some custom metrics in my controller. So here, if I go to the home controller, you note that here I have created a counter. This counter will count the number of views for the index page. This metric will be also available for Prometheus to scrape it later. Because I want to deploy this application into Kubernetes, I have created a Docker file in order to Dockerize this application. For that, I have this Docker file, which will build and deploy the application inside a Docker container. Then I have pushed this Docker container into Docker Hub. So for that, if you go to the Docker Hub page, where here I have my repo, you will find the image available right here. Then I have created the YAML configuration files in order to deploy the application from that Docker registry, and I have created a public server, a public service that will use load balancer in order to expose my application publicly on the internet. I have already deployed this application into Kubernetes. For that, I have created an AKS cluster on Azure Kubernetes service, which is the managed Kubernetes service in Azure. And in this cluster, I have the overview, and you can see that here I have a deployment already running, which is my web app. I have a pod running, replica set, services, and so on. And this is the public URL for my service. Now, if I go to that endpoint, I will find here my ASP.NET Core application running. And now my app actually exposes the default Prometheus configuration, and it also exposes my custom counter. So here, if I go to the URL /metrics, I'll be able to find the different metrics available from my application itself. And here I find my counter, which displays the number of views for my index page. Now we want to install Prometheus in the Kubernetes cluster in order to scrape those metrics and show them later on a dashboard. So let's do that. So first of all, I start actually with deploying Prometheus using Helm charts. Of course, we can deploy Prometheus using standard YAML Kubernetes manifest files, where we have to create the different files for the services, for the deployment, for the replica sets, and so on. But we have a more easy way to install Prometheus, which is using Helm charts. If you want to learn more about Helm, go to their website, helm.sh, where here you will find more information about how Helm works and how to install it. I have already installed Helm on my machine, and here, if we go to this repo, we'll find the different Helm charts that we could use in order to install applications into Kubernetes. So in a nutshell, Helm is a way for installing and deploying applications into Kubernetes. So instead of dealing with multiple YAML configuration files, and we need to configure those files manually, and we need to figure out how they work, Helm chart will create a chart or a package that contains all of those YAML files, and we can customize those files through using variables. So here, for this chart, which is specific for Prometheus, You can find here how we can install that chart, and you can find also the different parameters or the different variables that could be used in order to customize this Helm chart. So here you find, for example, the image repository, the image tag names, and so on. And we have also some other configuration for the service type. You see here we have different service types. The one I'm interested in is server.service.type. This one will define how I want to expose my public endpoint URL. Okay, so here by default the service type will be of type cluster IP, but here I want to change that in order to use a load balancer, because for demo purposes I want to expose my Prometheus dashboard on public URL. But for production, it's better to use other techniques like port forwarding and keep your those endpoints private. So let's go back now to the VS Code, where here I have a file called commands.sh, where I have written all the commands we'll be using in this demo. We'll have lots of commands, and of course this project is also available on GitHub. So if you go to this repo, you will find the different files we are using along with the commands. So let's start first by running the command that will install Prometheus in Kubernetes. So I'll use this command right here, Helm install, and from my command line, let's make sure I'm inside that folder where I have the commands, and then I'll run that command. And you see here, of course, make sure you have Helm CLI tool installed in your machine in order to be able to run Helm commands. Here I'm running the command Helm install. What I want to install here is the stable version of Prometheus. The name of that install is my Prometheus. This is specific to Helm, okay? And then I'm setting some variables or some parameters in this Helm install. One of them is, as we mentioned, is the service type, which is using here load balancer. Then I want to set the airbag to false. I don't want to create airbag policies because I want to keep this demo simple. So I'll keep this with false value. But for production environments, it's better to enable airbag, and here make sure you create the right rules and rule bindings. So this is the simple command in order to install Prometheus. Let's run that command. And here, first thing, it tells me that it could not find Tiller on my Kubernetes cluster, because now I'm using Helm 2.x, which should install Tiller into the cluster to be able to communicate with Tiller in the cluster. But starting from v3.0, we will not need Tiller to be installed on that cluster. So from here, I need to install Tiller on my cluster. So the way to do that is Helm init. With this command, it will tell me that now Tiller, the server side of Helm, has been installed into my Kubernetes cluster. Now I'm ready to run my Helm install for Prometheus again. And here the deployment did finish it successfully, and here it shows me all the resources that were created by this deployment. You see that here it did created some config maps, it did created persistent volume claims, did created pods, services, service accounts, daemon sets, and a lot of other resources. So this means now my Kubernetes or my Prometheus install was installed successfully, and here I can see the URL for my Prometheus. For that, what I need to do here is to run kubectl get SBC or services in order to get the services, and here we get the service for my Prometheus server, which uses a load balancer, and the public IP address or the external IP is this one. So I'll copy that IP address and I'll go to open that into a web page, and from here I should be able to access my Prometheus dashboard. Great, so now we have the Prometheus dashboard available right here, and from here we can see the different metrics that Prometheus scraped from the Kubernetes cluster, from all my resources, including the pods, the nodes, and the jobs and so on. And this huge list of metrics are now available from Prometheus, so I can see the value of any of those metrics. Let's choose this one, for example. If I run add the graph, or actually run graph directly from here, I'll be able to see the evolution of that metric that it appeared. It starts to appear from here, and I can see this visualization inside this graph. Great, but now in this list of metrics, I cannot actually see my counter that I have created as a customized metric in my application, and I don't see any of my application metrics displayed right here. Why? That's because we didn't configure it yet Prometheus in order to scrape metrics from my application. To do that, I need to change the Prometheus configuration. So let's first check what is Prometheus configuration. So when we say Prometheus configuration, we mean the Prometheus.yaml file, which lives inside the Prometheus server, and that file contains all the configuration for setting up the alerts and the scraping rules. Let's now try to view the content of the file Prometheus.yaml. To do that, I'll go back to my command line from here, and then I'll go run the command kubectl exec, which will allow me to run a command inside a Docker container inside the pod. So I'll tell it -it to run that in interactive mode, and then I need the name for the pod I want to access to. From that, I need to first run the command kubectl get pods to get the list of the pods, and then I choose the pod that runs the server, which is this one right here. Then I run again kubectl exec -it, then the name of my container, of my pod, and then actually we need to put the name of the container itself, because we might have multiple containers running in a pod. And here it turns out that when we install Prometheus with Helm, the Prometheus server will be always called Prometheus server. Then -- and here we put the command that we want to run, and the command here is cat to show the content of the file, and the file we want to show its content is in etc /config /prometheus.yaml. So let's run that command, and here it shows us the content for Prometheus.yaml file. And you see here we have multiple configurations for that file. It's YAML configuration file, and in some places we have the scraping rules. So if we go up here, we'll find that here we have the scrape configs, and in this section, this will describe from where Prometheus will scrape the metrics. So here the targets are localhost. So this means we'll scrape the metrics from the localhost, but if you want to add another target, which is our application running inside another pod, then we need to add that target right here. So to do that, we have two options. First of all, we can go to change this Prometheus.yaml file manually. Okay, we can access it and change the content by adding the new target. And the second option is using Helm charts, because with Helium charts we can customize the install, so we can access the configuration of this Prometheus.yaml from Helium charts. Let's do that from Helium charts. The content of the Prometheus.yaml file is described in Helium chart inside a variable. So if we go here to the Helium chart itself, if we go to open the content for values.yaml, from here we can see that we have multiple variables described right here, and if we go to search for Prometheus.yaml, from here we'll find that we have in this section we have the scrape configs, and by default it will look for the metrics from the localhost target. So if you want to change this value inside the Helm, we need to change the content of the values.yaml. To do that, simply I have copied this the content of this Helm values.yaml, and I have copied that into my VS Code, into my solution, and I have that value right here, which contains the same content as the values from the Helm chart. And to this I have added this line of code that will target my app service. This is the URL for my application, because web app service is actually what I have called my service. That is here web app service. Okay, so with this way Prometheus will add another target to scrape metrics from, which is my service that points to my web application, which is the container that runs my app. So this is the basic configuration we need to do in order to enable that. So let's now go to upgrade our Helm chart in order to take into account this this new file, which is the prometheus.values.yaml. So to do that, we need to run the command helm upgrade, and I have written here this command for you. So helm upgrade, the name of your Helm install, Prometheus, the stable version, then the same parameters as we have specified before, and then we add -f and the name of the values.yaml file that we want to use. And the content of this file will go to override the default values inside the Helm chart. So let's go to run that command from the command line. Once that runs successfully, this means now that Helm did upgraded the install, and now if I try to check back the value for the prometheus.yaml file inside the pod, by running again the command for docker helm or kubectl exec, now we should be able to get actually the new value, but here it tells me that the pod was not found. Why? That's because now if we run kubectl get pods, we can see that now there is a new pod that is created 85 seconds ago, and that's a new pod because Helm detected that there is a new configuration into that file, so it will go to kill the old pod and deploy a new pod. That's the way how it upgrade the pods. So now I need to run that same command, but using the new pod name, which is this one right here. And now we are able to see the new prometheus.yaml file. And from here, if we scroll up to the targets, we can see that now the targets includes the web app -service. Great. Now it's worth mentioning that this same configuration is also specified inside a config map in Prometheus. So if we go here to display the different config maps we have with Prometheus, kubectl get cm or config maps, you can find that here we have this config map specific to the server. I copy its name and I try to display its content through using kubectl describe config map, then the name of that config map. And here you find that we have actually the same content for the prometheus.yaml file, and along with that we have the section for the different targets displayed also in the config map. So if we update the config map, the prometheus.yaml file will be also updated as it gets its value from the config map. Cool, so now this means that Prometheus not only scrapes metrics from the cluster itself, but it also scrapes metrics from my application, and it will be able to scrape the counter that I have created. Now let's go back to the Prometheus dashboard. Let's go to refresh this page. Let's go to the list of the metrics, and from here let's look for our metrics called my counter. Actually, I can go to just search for that value here and here. Here it is, my counter metric, the customized or the custom metric that I have created in my app. I can see its value right now. So if I run execute, I can see the value displayed there, which is 19, which is the actual value that I get from this page. It was that easy how to install Prometheus and enable scraping metrics from the Kubernetes cluster and from my own application in order to use this data to visualize it. Follow me in the next videos where we'll explore how to visualize this data into more nice dashboards using Grafana. So see you then.